Hello, welcome to today's webinar on vineyard irrigation and specifically on soil moisture monitoring. I'm Mike Bauer. I'm the marketing manager at Ranch Systems, and with us today is also Mark Greenspan of Advanced Viticulture. Mark is well known in the field. I think most of you already know of Mark. In any event, he is a recognized expert in this area, and I think that's a bit of an understatement. As Mark takes you on an overview of soil moisture monitoring, you'll see that he's really just exposing the tip of the iceberg of what he knows. So we're fortunate that the Mark is joining us for this. So without further ado, let me go into the presentation. We're going to be covering three major topics. I'm going to start out and spend about 15 minutes talking about wireless telemetry and sensor technology and kind of the underpinnings, the technology infrastructure for doing soil moisture monitoring. Then Mark's going to talk about soil moisture dynamics and irrigation management schemes. Another way to look at this is I'm going to talk about the tool, the basic tool, and Mark is going to show you how to use it. To use a different analogy, I'm going to show you the car we built for soil moisture monitoring, and Mark is going to show you how to drive it. Now, as a driver, Mark is not really just any driver, but I think more of the NASCAR champion of soil moisture monitoring. And that's not too much of a hyperbole. Okay, so here we go. Okay, Ranch Systems, we have a hardware-software platform called RanchMaster. This is a wireless telemetry architecture that's used for the remote monitoring and control of vineyards. It basically consists of hardware building blocks and several solution areas that are supported by our online software application. And those are weather and climate, basically a full-featured weather station that includes things like mildew indexes, botrytis index, evapotranspiration, sophisticated calculations and analysis tools that you expect in a state-of-the-art weather station. Soil moisture tracking, which we're going to get into in relative depth today. We also do irrigation control. We turn on and off valves. We could turn on pumps. We could turn on engines. We could control wind equipment for frost control. So I think that's very significant. Supporting that, we have software tools that do irrigation scheduling and can even automate the entire irrigation process. We have a water level monitoring component where we can monitor levels of tanks and ponds. And we also have remote camera capability where we could place cameras in the field for remote surveillance and crop monitoring. Remote weather monitoring is another application that's used for. Supporting all of these five solution areas is an alerting function. And basically what that does is it enables any sensor condition, which includes what we have called virtual sensors, which are calculations based on multiple sensor readings, could generate an alarm, which is communicated for email or a text message or a phone call. For example, the most common alerting application is frost alerting or heat alerting in the vineyard. So that's kind of an overview of our platform. Again, 6 solutions, 1 basic modular expandable platform. Now I'm going to give you a better sense, a quick overview of the architecture and how it works and plays together. I'm going to go through this kind of quickly. So we have a lot of people that are already somewhat familiar with our solutions. So I'm going to just give this quick overview for people that are new to Ranch Systems and RanchMaster. Okay, we start off here. We have a weather station and what is called a base station, and that's the way a lot of our customers start, is with the weather station at the first building block. And that weather station communicates to the cell network, but it could also communicate to a Wi-Fi network if there's Wi-Fi in the area. Then the data that's communicated gets sent up to our online software application, which is residing in a data center up in the quote-unquote cloud. From there, you could access it with your computer over the internet and any browser. So that's you could view it remotely in your home office, but also if you're in the vineyard itself and have a tablet or a smartphone, you could access the information there through the cell network. Or if you're remotely located out of town, out of country, you could still access it through your computer or a smartphone. Okay, so that's how it fundamentally works. But now, if you want to add functionality, say you want to control the valves of the irrigation system, just add a node and a valve control unit. And that telemetry node then talks to the base station, which acts as a gateway to the software application residing up in the cloud. Next, if you want to add soil moisture monitoring, just add another node and connect up your soil moisture probe to the node. Notice that this soil moisture probe is talking to the node wirelessly. So that's a new development that's just around the corner, and that's what I'm going to provide you more details on in the coming slides. So that's an innovation that's going to change the cost-benefit dynamics of doing soil moisture in the vineyards. Okay, that node talks to the base station. I don't know whether you noticed, but I added a camera to the telemetry node that's doing the valve control, and now we could see what's going on, have a visual view of what's going on in the vineyard remotely. I just added a telemetry node by the pond. That node can monitor the level of the pond. It could also turn on and off the pump. Now, notice that that doesn't talk to the base station. It's quite far away. So it uses another telemetry node as kind of a repeating station to talk to the base station and send the information up to the server. So we have kind of a multi-hop mesh network which extends the range of our solution and makes it more flexible. Finally, we add a telemetry node at the tanks and can monitor the level of tanks. So that gives a kind of a sense of the architecture, you know, how you could expand it, and how the different building blocks can play with each other. So I just kind of glossed over that, but you could ask any questions that you like, and we'll address those at the end. Okay, now I'm going to talk about our new hardware telemetry node, the RS300. This is a new generation of hardware, and I think it can be both a cellular node, that means talk directly to the cell network, but I think more important and pertinent to our presentation today is its modular open architecture. So functionality could be added to it through 2 expansion slots. For example, you could add more sensor inputs, or more relay outputs for controlling valves. But I think most significantly to this presentation, it also accepts a new wireless probe card from Aquacheck, which enables it to talk to a multitude of wireless probes. So here's kind of the old way of doing soil moisture monitoring. We have 6 telemetry nodes, 6 corresponding soil moisture monitors. This is what looks like under the canopy. Here's over the canopy. By the way, this is not how they're normally configured this close together. This was at Hoodow Creek in Sonoma County, and it was kind of an experimental research project conducted by Mark and Sonoma County. So I think the thing to note here is 1 telemetry node to 1 soil moisture probe. And there's what a soil moisture probe looks like, and with its hardwire connection to the telemetry node. Okay, this is the innovation that is basically at hand. You could now, using an antenna kit, have that soil moisture probe talk over a wireless connection to the telemetry node. So you don't need a hardwired connection anymore. And here are the specifications of this solution, and that really opens up possibilities. Okay, first of all, you could now connect 10 wireless probes with 1 node. Instead of 1-to-1, you could actually go 1-to-10. I think more accurately, you could go 1-to-11 because you could still have 1 hardwired probe connected to the telemetry node. And you have a range of 1,000 to 1,500 feet. So that's kind of what the manufacturers, what Aquacheck's testing shows. So we're going to take that with the grain of salt that we're going to just kind of wait and see. But that's quite a distance. We're talking a quarter mile. You could really spread these around your vineyard and collect a lot more data in a lot of places and get more granular with your soil moisture monitoring. And I think I've been hinting, not hinting, but communicating that this is just around the corner. And by that I mean Aquacheck, it says it's going to be coming out with this in June. Again, we take that with a grain of salt. So we're going to say June, July, maybe even August. So you always have to take a manufacturer's release date with a grain of salt. However, you could still take advantage of this now. So I want to show the way to do that. You want to get your probes in the ground now, early in the season, and start to get the data, learn how to use the system. And you could do that by getting your RS300 system, purchasing that. That's available now. We're shipping those. And just get a standard wired Aquacheck B2 probe. And then you have to get the cell and software service with it. So we're talking about roughly $2,500. Put it in the ground now. Then in June or July, when the wireless probe's out, you could add the wireless card, $345, and then add additional probes for $1,350. So now On the next slide, I'm going to show the relative cost effectiveness of wireless probes and break it down to actual dollars and cents. Okay, so we're going to take a sort of a best case scenario on an 11 probe system, fully loaded, so to speak. So if you're doing that the old-fashioned way, on a 1-to-1 ratio, it would be about $26,000. Every time you added an additional probe, it would be $2,340 because you got the probe and the telemetry node. Now, with the new wireless architectural approach, you can have one wired probe, your base system that we talked about in the previous slide, and add 10 wireless probe. So again, now one telemetry node, 11 soil moisture probes. We're talking about $16,500 for that solution, and the incremental cost of each probe is $1,350. So a significant savings. So you're saving about $1,000 per probe. So all of a sudden, soil moisture monitoring, real-time, remote soil moisture monitoring is, I think, I'm going to say significantly more affordable. Now, with that, I'm going to segue to Mark, and you're going to actually catch him on his second slide of his presentation. We had some technical difficulties, and I re-recorded this front end. So don't worry, you didn't miss much. And at the end of Mark's presentation is a extended Q&A session going on for about another 45 minutes, where all people's questions about the wireless probes, and I think the preponderance of those questions are digging into vineyard irrigation and soil moisture monitoring.
But I do have a few case studies I could always refer to. So this is a flow chart I kind of came up with for irrigation. And those first two steps are pretty much just an investigation phase, if you will. Looking at your site characteristics and determining what your actual rooting depth is. Talk to you a little bit more about that. Understanding what your soil type is as well. I say type, that covers lots of things. The texture, the structure, the depth, of course, rooting depth is a function of soil depth, but also there could be other characteristics of soil that affect how you irrigate, like stratification, gravel or clay lenses, those kind of things. And then again, I think an integral part of irrigation is putting these soil moisture sensors in. I do very little irrigation scheduling now without at least one soil moisture sensor. Now, there's a few vineyards I work with that don't really irrigate, maybe irrigate once a year. Those probably can get by without a soil moisture device, and a lot of them I really don't push it on them, so we don't use them. But most of the time, vineyards that we do irrigate on a regular basis, we're putting these devices in. And I use these to determine the two aspects of irrigation. That's the volume and the interval. It's a little bit of an iterative process. That means we're trying it and we're making mistakes, and then we're coming back and doing it again, and eventually, and usually not in very long period of time, we can figure out the nominal irrigation method, which means how much and how often. But then we want to look at the plant water status, and I do believe that's very important. I still do monitor the vines on a weekly basis. We do the plant water status measurements in the field. And we have an idea of what we're looking for as far as stress levels. And we try to get to the stress levels. And if it's not at that stress level, whether it's too stressed or not stressed enough, then we adjust our irrigation, of course. I prefer to fix the volume more or less constantly, because I really want to irrigate to a certain rooting depth. Whether it's the full rooting depth or not, I want to irrigate to the same depth. And then I adjust the interval, the time between irrigations, before to adjust the plant stress. That's easy to say for a lot of smaller growers, but when you get to the bigger scale, larger organizations who are irrigating 20, 30, 50, 100 different irrigation blocks, it gets to be kind of challenging. But still, it's the same concept. So it's all about volume and interval. I don't know how well you can see this little cartoon because of the data rate, so I'll probably just skip over it, but it's just how often, how deep, and how often do you apply water. Water is applied to the root zone using drip irrigation. I think most of you who are listening to this webinar irrigate with drip irrigation, so that's how we irrigate, and it's different than other irrigation methods, so it's very different actually. And a lot of people don't really appreciate it, including myself until recently. I'm still trying to learn the nuances. The things I was taught in school were mostly furrow and flood. I was back in the ages where they actually did that. But drip irrigation behaves quite a bit differently in this soil. I won't talk a lot about the real fine nuances. That's really not what we're talking about here, but it just suffices to say it does move in the soil a lot differently than say a flood or a furrow, or a sprinkler for that matter. I've kind of modified my thinking a bit lately, so some of these slides I have in here, I left them in here on purpose, but my thinking has changed a little bit, and I'll explain what I'm talking about. To me, it's really only two things when we're talking about irrigation. It's how much and how often, the volume and the interval, and I'll probably say that 10 more times before my talk is over, but I'll try not to be boring. So how much and how often really depends on the soil in some ways. Shallower or lighter textured or gravelly soil cannot hold as much water as a deeper or heavier textured soil, and all those factors kind of combine together. There's other factors involved as well. Organic matter will hold moisture, or lack thereof will hold less moisture. So if we don't have enough moisture holding capacity, we cannot irrigate big irrigation. So just the soil can't hold it. On the other hand, if we have deep soil, the soil can hold lots of water. We could, if we wanted to, irrigate a big long irrigation and then wait for a long period of time between irrigations. Some people refer to that as the big drink versus the small drink. I'm starting to become more of a believer in the small drink, regardless of whether we have deep soil or shallow soil. I'm finding that at least for high-end wine grapes, that tends to be a better way of controlling plant stress, to irrigate shallow and more frequently. That doesn't mean frequent, it just means more frequently than otherwise. Still don't need to put that much water on vines. Grapevines don't need that much water, and that's really what these soil probes have helped me determine. That's the cover photo of this little webinar, but that's just me in a soil pit at that one of the those demos. That demo that we that Mike showed with all the radios in the air. With the those were actually AquaSpy probes in the ground. But here I'm just showing some guests at the demonstration where the roots are, and that's really what we want to do, is define where the rooting depth is, because we really don't want to irrigate below the root zone. It's a waste of water, and it's just a bad practice. So, well, I'm not looking for the lowest root. I'm really looking for where the majority of the roots are, say 80–85% of the roots. And usually I find that even in a soil like what I'm standing in right here, or sitting or kneeling in, the roots tend to be in the upper 3 feet, almost regardless. I know that people say roots can grow deeper, and they will grow deeper in some soils, 20 feet or more. But frankly, if you got 20 feet of rooting depth, you don't need to irrigate, so why are we worrying about it? But honestly, this is typically what I find is the top 2 to 3 feet usually contain the majority of the roots. Even in the North Coast, where we get about 40 inches of rain, there's ample soil moisture for the roots to grow almost anywhere they want to. They still tend to proliferate in the upper 3 feet. So here's a couple of extreme cases of shallow rooting depths, especially the one on the left. You see that scale. We've got about 8 inches of roots there. The reason for that is complicated, but it's not. Well, it's not super complicated. Essentially, it was not amended, and the soil is at toxic levels of aluminum in the subsoil, or actually below 8 foot. So the roots aren't going to grow into it because the pH hasn't been adjusted properly. That vineyard's been ripped out, but you can see that's a very shallow rooting system. In irrigating for several hours is essentially wasting our water. So we had to do in that scenario, just to keep the vineyard going, when it was still alive anyway, was to irrigate every day for very tiny shots of water, about an hour. The only reason we irrigated an hour is because it was on a hillside. Otherwise, it would have gone half an hour. And then the one on the right, that's a fairly shallow root system as well, about less than 24 inches, maybe about 20 inches. It's hard to say exactly, but I find that pretty commonly, these shallow rooting depths. This next slide here is an image, aerial image, with something called an NDVI. Most of you know what that means, normalized difference vegetation index, but we're not really talking about that today. So the idea is the greener areas are more dense foliage, and the redder areas, the orange areas, are less dense foliage. So the weaker zones, the weaker vine growth occurs where the more reddish orange color is. But if you see over here, I'm going to see if I can get my spotlight up. There, I think I can get it. There's your pointer. If you see over here, this is where that photo was taken from in the last slide, about 20 inches of rooting depth. The question is, this block is oriented like this. This block was planted well before they really paid attention to this stuff, I guess. The block is sort of like this. This goes in this orientation. So the rows are going north, northeast. But we're irrigating that heavy, deeper soil, deeper rooting depth that has 41 inches of roots, along with the rooting depth of 20 inches. So how do we deal with a situation like that? And honestly, every single vineyard I've ever been in has something like this. It may not be this extreme, but there's always a weak area. And the thing I see people doing is usually the wrong thing. People like to put in extra emitters in the weaker zones. In a sense, it helps a little bit because you're spreading the water around, but really, this is a weaker vine. It actually needs less water than the stronger vine. But ideally, what we want to do is have this all the same color, all the same vine density. And if that's the case, then they all need the same amount of water. So I don't want to give them different amounts of water. I want to water them more intelligently. And on my next slide, I guess if I have the laser pointer, I can't advance the slide. So maybe I'll get away from that. There we go. Okay, so this slide here is representing on the left side a shallower or weaker soil. It could be anything. This could be over here. It could be gravelly. It could be sandy. It could just be shallow. It could be rocky. And in the same row over here on the right side, we have more water holding capacity. Doesn't have to be deeper. That's how I showed it here. But it just essentially means there's more water holding capacity on the right side of this hypothetical vine row than on the left. And so what we have here is our drip system here, hanging here, with the 2 drippers per vine. How do we deal with this, which is really a representation of that last slide in real life? The first thing we do here in the North Coast, and this doesn't apply everywhere, but in the North Coast we're really using rain-fed water in the springtime and waiting to irrigate. We irrigate usually when the water's been partially depleted. The rain-fed water's been partially depleted, and then we start supplementally irrigating to get the vines through the rest of the season. But since the part on the left will dry out faster than the part on the right, we usually run an extra drip line. It's a little expensive, but really your volumes are worth it. So we tend to do that, and we put in these emitters where we have to irrigate first. It's even better if you design the system properly and you have your riser here, so you don't have to have this extra drip line here, but that's not usually the case. Nevertheless, we'll put in the extra emitters, we'll irrigate there first, and then once these vines on the right slow down, start running out of water, then we go to the main hose. So we're not switching back and forth. We're only switching back and forth once a season. Now, if we irrigate to sort of the middle or the heavier part of the soil, we have a problem, and that's really what I try to get through to people. Our problem is that we're doing fine over here on the right side, but here on the left side, we've irrigated too much, more than the soil can hold, so we end up losing moisture. So water can do one of many things. One, it could percolate below the root system, which I've kind of shown here. It could also move laterally underneath the soil, underneath the surface, or what's more common to see is water can pond on the surface and run off. We'll typically see that on a sloped vineyard surface where the water ponds and tends to run down the wheel tracks where it's compacted. Anyway, no matter what you do here, you're wasting water and you're creating a worse problem than you had before, because not only are you irrigating too much, but because you're losing moisture, in many cases you're actually irrigating the part that needs less water. You're putting more on there. I know this is a hypothetical, kind of a rough way to show it, but what happens is if you're irrigating to the right side, oops, if you're irrigating to the right side, by the time you get back to your next irrigation, this side's weak. It's run out of water already, while this one has plenty of water. So the real answer to that is to irrigate shallow. So we tend to irrigate to the weakest or the weaker part of the vineyard. That means shallower and more frequent seems to work. And that's why 9 times out of 10, I find that shorter or frequent irrigations are better than the longer ones, because every vineyard has a weak spot. Now it also is, getting back to the soil moisture monitoring, that's usually where we put the probe, in the weaker spot, because that's where we want to control the vineyard. Irrigation is in that weak spot. So a little bit about monitoring, and then we'll focus mostly on soil moisture today. In fact, we'll focus solely on soil moisture today. I'll probably mention some of the other stuff, though. Really, the irrigation dynamics, the soil moisture dynamics tells us how much and how often, but we also need to know, how stressed are the vines, which is why we have other tools. But soil moisture is the most, is the device we're focusing on. The visual indicators, though, those are free. I always really stress people to use the visual indicators of the vine stress as a device itself, and that's really important in the early season like now here in the northern hemisphere. I don't know if anybody's tuned in from the southern, but the visual indicators of vine growth and shoot elongation are extremely telling on how stressed the vines are. And in the North Coast, and most seasons, we're waiting for them to stop growing before we even irrigate. This year's a little different. We've got a little drier conditions, so that's not always the case. But generally, in most years, that's what we're looking at. But there's also these other plant water status instruments: the pressure chamber, the pressure bomb, which I already mentioned, the pyrometer, which I often talk about. I can show you something if we have any questions at the end of the session. But I've basically skipping over that section of my talk. And then there's some other devices, the sap flow gauges that are available. And something else that's pretty cool that we're looking at is the petiole diameter. These little micrometers that go on petioles that look at the shrinking and swelling of the tissue actually can be a pretty good indicator of stress. All right, so just focusing on soil moisture, though, there's a few key things I wanted to mention. One is, if we measure a soil moisture at one location or one depth, we're pretty much wasting our time. Not entirely, but pretty much. So I focus on measuring the full profile. That means at multiple levels. I'd say minimum 3. The AquaCheck probes have, at least the ones I use mostly, have 6. And I find that to be very useful to really get a picture of the profile, the wetting profile and the drying profile. In measuring continuously, again, really important. I already mentioned that. I think that's the new technology. Allows us to get beyond the weekly snapshots. I hope to show you why that's important to me. It's important to place the sensor in the right location. I found that we can't get too far away from the dripper. I don't want to put them right under the dripper, but I'll tell you, it's very important to put it really close. So I don't want the dripper to drip on the sensor, but I do want it to drip close to it. And we usually put them about 4 inches away. And I'll show you an example of a case where it wasn't done that way, and we didn't get a good measurement, so we had to reinstall the probe. Use this information to get the volume per application. That's because we're gonna do some little trial and error to figure out how deep we're irrigating per a fixed amount of water, and then we'll change that until we get to the depth that we want. and then we're going to pretty much use that volume throughout the season. But the thing we're going to vary is the interval. And the interval is going to, again, go back to these soil moisture devices to tell us how often it takes from our last irrigation to get back to the same point. Or maybe we want to get more dry. But this will take all the guesswork out of how often to irrigate. We want to use it in conjunction with the plant moisture status to precisely adjust the intervals, but that's feedback. Not everybody's going to go out and get all these devices, and I don't think you necessarily have to. You can get a lot of information just by looking at the soil moisture curves. But ideally, yes, you plug in a pressure bomb or a pyrometer or both to your regime and get the whole picture together. So skipping ahead, just going straight to soil moisture, and that's all I'm going to really talk about today. There are really two different types of sensor, basic types of sensor. One is the matrix potential sensor. Those are on the left. Those are some examples on the left anyway. On the right are the soil water content, or the volumetric water content probes. There's a big difference between the two of these. Those on the left measure the matrix potential, or how tightly the water is held in the soil matrix, which is a really good indication of how stressed the vines might be, because they're the ones that are actually pulling the water out. And so when the water is held tightly to the matrix, in other words, like you have a wet sponge, when the sponge is fully wet, it's pretty easy to wring it out. Once you start wringing more water out of that sponge, you have to squeeze harder to get that water out. It's the same thing with plants, although they're sucking water out instead of squeezing it out. But really, that's what these guys are measuring on the left. So we have a watermark sensor on the left, on the far left, a green sensor. Those are probably the most economical sensor out there. They do have a limitation on their range. These here, this is the MPS-1, which has been replaced by the MPS-2. This is a decagon device, a very good granular matrix sensor, just like the watermark. It's about 3 times the price, but it has twice the range. So in other words, it'll cover the drier range much more effectively than the watermark. But they're both very good sensors. I'll tell you, I like these sensors a lot, but the one thing they don't tell you, there's some limitation on what you can do with these that you can do with these, you can't do with those. These, I mean the volumetric sensors, and I'll talk to you a little bit about that in a second. There's a couple different types. This is, of course, the AquaCheck, which I'll talk about. It's a self-contained probe, has all the sensors embedded in it. And then there's discrete probes. This is the decagon type. There's also a grow point sensor. The idea is they both measure, these all measure water content the same way. The neutron probe, by the way, is also a water content sensor, but it's not something you can hook an electronic device to because it can't be left in the field. So this is these are in the same family. I'll talk to you a little bit about how they work. But really quickly about the AquaCheck probes, that's the slide, the image that Mike showed you. It's really a derivation of this original Centec probe from Australia, which was spun off by a company called C-Probe, which eventually became AquaSpy. And then C-Probe was, I'm getting some message here that no one's hearing me. Is that correct? Mike, can you hear me?
I can hear you.
Okay. All right. Hopefully everybody can hear me.
Let's see.
All right. I guess we're back. We're good.
Okay.
I got 98% now. Yeah. All right. Well, I'll keep going. Hopefully everybody can hear me okay. I'll skip over this pretty quickly because we got to get to the meat of this pretty soon. But these are the probes that we really like. These have 6 sensors, but AquaCheck does have a probe now that has 4 sensors. I prefer the 6. There's a little bit of a price difference, of course, but you know, I like the resolution that 6 sensors gives us. I like these a lot better than the other probes because if you notice on the photo, they're fairly narrow. They're only about 1.25 inches in diameter, so they're easier to install. Less soil disturbance and pretty relatively easy to put in. We have a way to do it. It's even easier. But anyway, that's besides the point. They do come in different lengths. They do come in short lengths for like agronomic crops, like field crops. But for grapes, we're usually using 32-inch to mostly 48-inch probes. Occasionally, we'll have somebody who wants a 60-inch probe, and there are some 60-inch probes available, but primarily we're using the 4-foot probes, which have sensors at every 8 inches. Okay, this is my bad diagram, the best I can do using PowerPoint of a probe in the ground. And as you'll see, as you notice, there's a little, these are supposed to represent electromagnetic fields around the sensors. So the sensors are embedded inside the probe. You'll never touch the soil. You know, they're encapsulated in this resin, and then they're surrounded by the this nylon tube. So they're all sealed up. And the way they don't really touch the soil or the soil or the water, but what they do is they interact with the surroundings. And so there is something called permittivity or dielectric constant. So a lot of you probably heard of that before. Let me back up just a second. So soil is really 3 phases. There's the solid phase, which is the minerals or the organic matter, the stuff, the hard stuff. And then there's pore space. And the pore space is either filled with air or water. It turns out that water and air have dramatically different dielectric constants or permittivity properties. And so it's that fundamental physics phenomenon that they're exploiting for this measurement. And so what happens is this device sets up an electric field around each of these sensors, and it measures how it's influencing the device. So it's really measuring a capacitance, which is over some of your head. Some of you don't want to even know that, but really what it's doing is measuring it's measuring the capacitance of each one of these capacitors. And that's translated into water content measurement. Very simple. You don't have to know all that. Just know that it works. I'm just going to go over this really quickly, but a lot of people want to know the actual volumetric water content, and I'm going to tell you why you don't necessarily need to know that. I use these probes uncalibrated, and we calibrate each one individually based on our irrigation practices and our vine stress, not really based on the actual calibration curve, but that could be done. But here's just a really crude example of a flood irrigation on the left versus a drip irrigation on the right. So I know this should be obvious. This is obvious to all of you, and I hate to even talk about this, but we're not irrigating uniformly across the field. We're irrigating in spots. Okay, just realize that. So traditionally, these devices are used in a calibrated format. So we actually measure something, and then we calibrate that to something called volumetric water content, which is really how much water, what's the volume of water for the same volume of soil, or the soil, water, air. So if we take a meter cubic foot of soil, water, air, how much of that is water? That's really what we're trying to measure here. Now, if we do this with a calibrated system, then we want to know that exactly, or very close to what that is. Normally, what we express water content in is, at least in agronomy, is inches of water per foot, inches of water per foot of soil. So we're not really talking in 3 dimensions. We're talking in just the depth, 1 dimension really. And we can do that if we're dealing with a irrigation system that wets continuously in a horizontally continuously uniform fashion. And how we figure out how much water we need is we take the volumetric water content after a bed of drying minus the volumetric water content after your irrigation times the depth of the root zone, and we get the amount of water we need to replace that water. And that's all great. I know I'm skipping over this really quickly, and the reason I'm doing that is because that's not very useful for drip irrigation. Because when drip irrigation, we don't have a uniformly wetted soil, and so when we measure this property, it's going to depend on where what the property is depends on where we measure it. And because we're not measuring it consistently, it becomes really meaningless. So I use these probes in a relative water content format. A lot of people kind of scratch their head over that, and I find that works just fine. Really quickly, we did this little trial at that Sonoma demo where we measured, if you see the emitters right here, drops right here at 0, and then we measured water content. Now these are watermark sensors, they're not the volumetrics. But we measured it at right under the emitter, 9 inches away, and then 18 inches away, and then we measured it at 1, 2, and 3 feet of depth. And what we wanted to do is get a cross-section of wetting, and this is kind of doctored up a little bit. I basically measured these points, and then did a interpolation between the points to get a picture of where the moisture was. This is not volumetric. This is soil water potentials using those watermark sensors. But what you'll note is that the wetting pattern kind of bows out here, but it only goes about to 9 or 10 inches. This is pretty dry over here, where it's around 150 to 200 or more kilopascals per centibars. That's pretty dry. So basically, the wetting pattern looked like this, if you see what I'm drawing here. But it didn't go very far away. That means if we put our sensor here at a foot away, we're missing the whole picture. And I've seen a lot of people do that, and what happens when they do that is they essentially want to irrigate too much because they don't think they're getting their moisture down there. But if we measure it right here, we're really measuring the core of the cone, if you will, the core of the bulb. We find that when we measure it that way, we don't need that much water. So I don't really bother to calibrate it. To calibrate these things is actually very difficult and expensive. There are calibration equations if you're more comfortable with it. AquaCheck has 8 calibrations for 6 different types of soil, which can be used. And if that's what you're looking at, then we're more than happy to oblige. But I don't really need it. What we really need is a repeatable, and I say precise, measurement. So I don't even care how accurate they are. I want to know that that is a repeatable measurement, that when I put the water on, and it tells me when to put water on again. And that's what I'll show you in a second. And I'll skip that slide, move here over to here, because I'm probably getting a little long in the tooth, which I tend to do. This is a chart, not a very good irrigation, but just a chart of the soil moisture. And what you see is a bunch of colors. Each color represents a different level in the soil. So the blue line is 8 inches. The red line is 16. You may be able to see that on your screen. And the pink line is 24. The green line is 32. So, and progressively deeper. So this is a 48-inch probe. Every 8 inches is represented here. What you'll notice right off the bat is that these two, this orange line at 48 and this brown line at 40 inches, are not doing anything. So there's essentially no activity there. And that's actually what we verified with the backhoe pit. There's only roots down to about 36 inches. What you also notice here is that where we do see uptake, we have these little stair steps. The stair steps are indicative of the diurnal uptake and the nocturnal, the nighttime lack of uptake. So this is a really good identifying signature for seeing where the roots are active. And you'll notice we have a lot of activity in the upper levels. We start getting diminishing activity in the lower levels, but we do see the ripples. When we see these ripples, it tells me that's where the roots are. And 9 times out of 10, or maybe even more than that, we find that's exactly what we find when we do backhoe pits. But you also notice a couple other things here. These are irrigation events. This irrigation here, we see this spike up in these 3 levels. So the blue, the red levels, and actually the pink, or the magenta, that's at 24 inches, spike up, which means the water went past that zone. But this green one is delayed. If I could zoom in, which I can't do at the moment, you see it's delayed, and it's actually more of a gradual rise. Again, you can't really see that at this magnification, but it tells me that the water percolated down to somewhere between 24 and 32, stopped there, and then it's to continue to move out with capillary movement. Redistribution is what it's called in irrigation, to 32 inches. So that, to me, is a pretty good identification signature of an irrigation, and it goes down to about 30 inches, and that's about what we want. in many cases. Sometimes we want to go shallower. This, again, is not a really good irrigation cycle. I'll show you some better ones. But it does point out a few good things. Now, what is this? This is a single line, and really what it is all these lines summed up. So this here, and I always forget that you are getting a delayed picture here, but this here is a summation of all of the previous. I guess I didn't describe this very well, but I'm getting ahead of myself a little bit. This is the previous slide again. On the left side is water content, but it's relative water content. The higher the number, the more wet. And so these aren't calibrated, so these numbers are not too meaningless to anybody, but I have a pretty good idea where we usually fall. So in this scale, 0 means dry, bone dry, and 100 is basically a bucket of water. We typically find readings between 50 and 85, 90 in these measurements. So this slide here, again, going back to this slide, is a summation of the water in the profile. So this is a basically meaningless number here. I don't really even look at the y-axis, which is why I tend to not forget to explain it. I'm really looking at the patterns here. And then I set my reference lines accordingly, which is why I'd say we calibrate this to every site. So if you notice, each one of these is an irrigation. The water content goes up, and then it falls. But you notice a couple things here. I'm going to skip some of this description. The AquaCheck has a term. I'm not sure how commonly it's used. That's not something I use often, but it's actually a pretty good concept. Something called RAW, or readily available water. But you see after the irrigation how quickly it depletes the moisture. After a while, you kind of see a change that it's depleting more slowly, and then it gets even more slowly. What's happening here is the vine's getting more stressed, and when it gets more stressed, it closes its stomata. The stomata pores, transpires less water, and takes up water less rapidly. And so what we can do is use this curve, not the one above where I showed you all the levels. The level chart's great for determining how much. This is really what gives us the tool for determining how often. And so we can set our reference point for irrigation, for our next irrigation, anywhere we want. If we want them to get stressed, then we put it down here. If we want them to get less stressed, then we maybe put it up here. So if we're growing Pinot Gris, maybe we want or Chardonnay, maybe we want it up here. If we're growing Cabernet Sauvignon, maybe we want it down here. And so we can adjust the stress by looking at this inflection, or the slope, more than the inflection. So you see that there is my little pictorial there. It's coming up on your screen. Green means not stressed, or yellow is more stressed, and red is much more stressed. And we as a advanced viticulture, we also measure plant water stress to confirm these. But this is a pretty good indication of stress without doing anything but looking at the soil moisture. And that's why I always go back to this. So important to measure the dynamics of soil moisture, not just the actual soil moisture itself.
Mark,
this is a quick.
We're at the top of the hour, so probably go over another 5 or 10 minutes, and then we'll go into questions.
Okay, I'll get going and finish this up in a few minutes. I wanted to show you this really quickly, though. This is just, I want to reiterate how important it is to put these sensors in the right place. The chart on the top is just that slide I showed you already. It's miniaturized there, but you see how sharp the moisture goes up almost instantaneously. Each one of those dots is actually half an hour. So it's really quick rise. You want to see that in your device when you're measuring soil moisture. This is one that was put about a foot away from the actual emitter. And what you'll notice is this blue line here is the shallow one. That's 4 inches. The green line here is 8 inches. The red line is 16. We really don't see much change after the irrigation. The irrigation was applied somewhere around here, somewhere here on August 5th. But we don't see that sharp rise. In fact, we only see a rise at 32 inches, which is kind of what I showed you a couple slides ago, where we saw that edge of the wetted bulb. So we're kind of measuring the edge of the wetted bulb. We're not really measuring the center of it. So it's very important to put your device in the right place. Actually, the easiest thing to do if you don't is just plug your emitter and put a new one in, or put a spaghetti hose so that you're actually dripping right on or near the sensor. I can't tell you how important that is. Now here's a pretty good irrigation cycle, so I wanted to show you this before we fade away. This is a vineyard in Sonoma Valley. Fairly repeatable irrigation. You'll see here that they irrigated. So let's look at this one here. This irrigation here went to about this magenta line, which is 24 inches. It didn't get to 32, so we're going fairly shallow here. 2 feet is a pretty good irrigation. And then it gets down to a certain level, and we irrigate again. In this case, it didn't wet as much, but we've got it dialed in for about 20 to 26 inches, I'd say, of wetting, which is pretty good. And then, but again, realize this is used for determining, in my mind anyway, determining how far the water goes down. This is the summation chart of soil moisture. And again, you see the irrigation, a fairly shallow irrigation. We've set these 2 points. I've set up what I call a full point, sort of arbitrary. The most important point is this refill point, the trigger point. And that's really where the magic comes in. So that's what we're setting to tell us where to irrigate again. In fact, in ranch systems, you can use this as a signal to send you a text message when to irrigate again, or even better, to turn an irrigation valve on. So this, in theory, this could be, and in some practice, it could be automated, and this could be your signal to automate. So I like this because it's a fairly repeatable cycle. So I give this to somebody, give them a system because he's a former intern of mine, and I gave kind of as a gift a set, a node and a probe, and I wanted him to try it out. And so he has this vineyard in Napa, and it's a younger vineyard, and he wanted to irrigate, not to stress it, he wanted to irrigate to pretty much to the bottom of the root zone because he wanted to encourage deeper rooting. But realizing that he didn't have much root activity, if you look at this black line is 40 inches, and this magenta line is 32. Not a lot of going on down there at that level. So realizing how deep he wanted to go, he wanted to get it just a touch around 32. This is his first try. He didn't get it very deep, so he irrigated again the next time, deeper irrigation, just noting that he went down, got moisture down to 32. So it took him about 2 tries, maybe 3, and then he got his volume down. And then he went to this curve here. This looks a little different because this is actually through the Ranch Systems interface. The other one was a desktop software. Ranch Systems interface gives you the real-time information, which is what we really are the state of the art today. But you'll notice that we've also set the bar upper and lower using this blue bar, which you can do in the software, in Ranch Systems software. And so this is our full point, and this is our trigger point. So after a couple of iterations, he determined his irrigation cycle. And you see he did a pretty good job of getting it through the season, the rest of the season. We put this thing in July, and by August he had it all figured out. So pretty cool. The other thing I wanted to point out is that I don't use ET anymore. You can still use ET, and these weather stations will give you ET models, and some people still want to use them. I don't discourage people from using them, but one thing I like to point out is this particular example, and almost every example I've done this exercise is I looked at our irrigation regime relative to crop ET, and you see that I've got crop ET measured nearby. I measured 2.21 inches, which equates to 66 gallons per vine. We irrigated 12 gallons per vine during this time period, which I've shown with this arrow. From this irrigation and this irrigation to the point of our next irrigation, we irrigated 12 gallons, equating to 18% of ET. And so 18% is pretty low. A lot of people will call 60 or 50% deficit irrigating. In fact, I call that surplus irrigating. So this is a really good tool to save water, because irrigating at 18% of ET is a lot less water than what most people irrigate with. Then going back to the short and frequent, and I'm going to have to I think I need to scoot here, so I'll go over this really quickly, but I've learned in the last few years that going with the shorter, more often irrigation, the small drink, tends to get us a more stable plant water status. So this is, again, I haven't talked about stomatal conductance or leaf water potential very much, but this is what this is. This is a Merlot vineyard, and you see that this is leaf water potential, this blue line, and kind of the target zone is the shaded zone. We got it there, and we kind of held it there for the whole season. This is the stomatal conductance, which dropped rapidly. Once we started irrigating, we kind of dialed it in. We did the short, frequent irrigation. We kind of held it there. This stomatal conductance is this is the zone. It's the left side here, this left axis. I don't have time to go into the details there, but we got it into the zone and we kept it there with the short, frequent irrigations. On the other hand, just down same vineyard, different block, we had a deeper soil. It was Cabernet Sauvignon, so we wanted to give it deep irrigations. And the problem we had here was the vines, A, weren't stressed enough. This is leaf water potential. We only got up to about 13 bars, which for Cabernet, fine wine, is not enough. But the stomatal conductance, this is our target zone, bounced around all over the place because when we irrigated, it'd go up. When we left it between irrigations, it would get back down into our target zone, then it'd go back up. I found that by doing this shorter, more frequent irrigations, we're able to get some of this bouncing around to diminish, which is really what we want. So that's pretty much it. I think this is just you can copy on this if you want to look at this. We're doing a little demonstration project with the Sonoma County Wine Grape Commission, but anybody in the world can look at it. This is one of the sites we're doing. It's a site in the Alexander Valley, and we've got a couple of probes placed in there, 2 different blocks, same clone, same rootstock, different, but we're going to irrigate them a little differently. We did this last year, so you can look at last year's information, but we're going to be doing it again this year. So if you log into the ranch systems, click on My Account. The property name is Redfan, and the username is SCWGC, which is Sonoma County Wine Grape Commission, and that's the password, CUPNBLNT. I have no idea what that means, but that's what they gave me for a password. So anyway, write that down if you want to log in later. You can poke around, kind of see how things work. This login doesn't let you change anything, but it does let you look at stuff. All right, I think that's all I have, so I guess we're open for questions.
Mark, let's go back to that login information. Keep it there for a second and
okay.
Give people a little bit more of a chance to pick that up. Well,
sure.
That was great, Mark. Thank you.
You're welcome.
I was particularly blown away by the water savings and that you get over using evapotranspiration, and also the how much control you get with the short and frequent. That was very compelling, the way that you showed that.
Yeah, I mean, I've done that little ET example several times, and I don't do it everywhere because we don't really use ET. But once in a while, people want to know how much they compare and how they compare, and it almost always comes out to about 20% plus or minus a little bit of ET. And that's crop ET. In that case, I used a 0.5 crop coefficient, which is pretty modest. There's a lot of error involved with ET, but that's it's still a good method if you got a large vineyard to manage. But I tend to find that we're always really low on the percentage of ET.
Okay, so let's see, Mark, make me the presenter back, and I'll show both our contact information.
Okay.
On that slide, and we're going to go through questions here. We still have pretty much everybody on board, so I unfortunately can't unmute everybody. There's just too many people, and there's too much background noise for that to work. So we're going to work our way through the questions. We'll get through all of them. We've got approximately, I think your drop dead time is 10 o'clock, Mark, is that right? Or maybe a little bit before that?
Pretty much, yeah, not too much more.
Okay. A lot of questions here. So, okay. first question, why so many probes so close together in the photo? That was back at the Hoot Owl Creek, Sonoma County, on that photograph.
Yeah, that's a good question, and it probably we should explain it. That's not a normal scenario. What we're doing there is comparing different irrigation approaches from anywhere from short frequent to long and less frequent to waiting for certain pressure bomb levels to get to certain levels to what ended up being dry farming. So we were doing a comparison, and that's why so many so close together. Now, of course, if we did that again, we'd use the wireless probes as soon as they're available, and we'd wouldn't have as many nodes up there. We would have one node and a bunch of wireless probes, in our project, which actually makes a good design for an irrigation experiment or demonstration project now that we have this new technology. But that said, yeah, that's why we had so many nodes in one location. It was definitely overkill, but it was there for a reason.
So, Mark, how many? What determines how many probes you use in a vineyard? 1, 2, 3, 4. What kind of drives that decision?
Budget.
I mean, if budget wasn't a factor, how would you ideally set up a vineyard for soil moisture monitoring?
Yeah, that's a really good question. That's a question I get asked more often than anything else. And of course, I am not trying to sell more than people need, because it's not my objective. My objective is to give them the right information, the minimum amount of information, because frankly, too much information is mind-boggling. Again, stepping back a little bit, that's why I like the Aquacheck probes. They only have 6 sensors, whereas some of the other ones have 15, which is just way too much information. And the same thing goes with having a number of probes out. If you got 20 probes out there, you've got a lot of information to digest. I do know one particular grower that I've worked with has 30. That's well, actually, I know one that has about 50, but anyway, they're large operations. But for us, a nominal size vineyard, or normal average size vineyard, you can get by with as little as 1 if your soils are all pretty uniform and you only have 1 irrigation block. So I typically want to measure every irrigation block you have. That said, if you got 2 or 3 blocks that have very similar soils, they may not be irrigated exactly together, but if the soils are very similar, same variety, same rootstock, then you can kind of group them together and put 1 probe. So I like to put a probe with every different kind of condition as much as possible. And of course, it does go back to economy. But, well, if you got a same soil type, 2 blocks, one's on 110R and one's on 114, well, they're going to behave very differently. You're going to irrigate them very differently, potentially. So you may want to monitor both of those separate. But if you have the same rootstock and 2 different soil types, then you probably want to put 2 in as well, because you got that variable as well. And then on the other hand, you may have Cabernet and Chardonnay, which you're going to irrigate very differently. So it really depends on how many. You kind of step back, look at how many different variables you have in your vineyard, variety-wise, rootstock-wise, and soil type-wise, and then you put your probes in according to those main differences. So you may have 2 or 3 or 4 or 5 main variables there that are in play, or 4 or 5 different conditions. Ideally, you want to monitor each one of those separately. And so when I talked about how to irrigate shorter, more frequent, it applies to a lot of situations, and that's why I put the probe in the more weak spot. Maybe not the weakest line in the whole vineyard, but the weaker 20%. We use the aerial images quite a bit to identify where the weak zones are. That's a very useful tool. And then we'll put the probe in to represent that block in that location. So you don't need multiple. You definitely don't want multiple probes in the irrigation block, because that'll just really be confusing. And it's really, I don't find that ever to be necessary. So a minimum set based on the conditions is all I can really say.
Okay, great. So next question, is it possible to use plant hydration level monitor systems instead of soil monitors?
Yeah, you can. Again, though, I found that the best way to monitor irrigation and schedule irrigation is with the soil. There are devices, and of course, I think my first slide, besides after my title slide, kind of showed the evolution of my thinking. Then I started using just plant-based sensors. The plant-based sensor thinking was that if I'm measuring the plant, that's really what I'm growing. If I keep my eye on the end point, then I can kind of control how I'm steering to get to that end point. But what it doesn't tell you is there a bend in the road? I'm using the road analogy a lot, but it doesn't tell you how much is stored. It doesn't tell you where your irrigation is going. It doesn't give you that precision on determining that after I irrigated, how many days does it take to deplete all that water? And that's what you're missing if you're only measuring the plant. So I prefer to measure both soil and the plant. But if I only had one to measure, I'd measure the soil in the way I described today.
Okay, next question. What size probes will be available as a wireless solution? I could field that one. It's basically the same sizes that are available now, and I think there's the 48-inch, which I think Mark, you recommend, but there's also, is it a 36-inch that's also available?
There's a 32, a 40, and a 48. There's also a 24, but I don't see any vineyards using 24s unless they're really, really shallow. But yeah, and there's also a 60, but the 60 is not currently in wireless form, so I don't know if that's ever going to come in wireless. 60 inches that is. So typically, though, most of the time we're doing the 48s. Once in a while we'll hit bottom. You're drilling through bedrock or some really tough material, and we'll have to put a 40 in. So 40 to 48 seems to be the most common that we put in.
Okay, next question is, do the wireless probes require line of sight to the base station? We have rolling hills out at our vineyard. So I think generally line of sight is ideal and required. So if you don't have line of sight, then you could set up an additional telemetry node in as a kind of a multi-hop communications network. Do you measure drain down? Has this been an issue or concern with any of your smaller volume, higher frequency irrigation strategies?
Does that mean drain down as far as the system draining, like in a hillside vineyard? I assume that's what they're asking. Yeah, I don't measure it, but that is an issue, and that is a mitigating factor for that can be an issue with. Sorry, the phone's ringing and I can't get it. So that can be an issue where with the hillsides, and we typically have to. That limits how short you can irrigate, because you will get a certain amount of drainage from the system from the top of the hill to the bottom of the hill, so the bottom of the hill always gets more water than the top of the hill. That said, it's not a huge amount of water. People think there's a lot of water coming out of that tube. I've calculated it before, theoretically. It's not a whole lot, but it is substantial, and there can be a fill time issue as well for the water to get pressurized to the top of the hill versus the bottom of the hill, so there is a differential on how much irrigation gets applied. So for hillside vineyards, that is a limitation. You can't go with just an hour irrigation. It's going to extend the minimum amount of time that you can put on. So I mean, that'd be easier to measure too with soil moisture probes, but I haven't done that. That's a good question though, and it does come up once in a while. People say, I want to go short frequent, but I've got this steep hillside vineyard, and I have to say, well, then you're going to have to go with maybe 2 or 3 hour irrigation sets, and then that's still pretty short. It's still a lot shorter than 8 hours, which I've heard a lot of people do. In a hillside, you're going to have shallower soils anyway. So there's that consideration. It's just a real practical consideration is on hillsides on that it can't be too short.
Okay, great. Next question. I have my soil moisture probes 4 inches from a drip emitter, and I am concerned that the water may be moving more quickly through the slurry around the probe than it moves through my overall soil profile. How do you know where to put the emitters in relation to the probes?
Well, 4 inches is generally what I do, and I found that to be pretty acceptable, or very acceptable. I have had one situation where I saw water. Well, I thought water was going as you say, down the side of the probe or through the slurry, where it kind of cracked away. In that case, I had to reseat the probe. But generally, if you have water going down the probe, I would if you think that's carrying, then I would put the probe, if it's sloped. If it's sloped, I would put it on the emitter on the down slope, so it's not running right into it on the surface, because that's really the only place it will do that is at the surface. If that's an issue, then you can mount a little bit of soil around the probe, so it's kind of got a little anthill kind of cone at the top, so it doesn't do that. Usually, when we do that, we do the slurry. We're very careful about installing it so that the slurry is put in the hole first, and then we put the probe in after, so it pushes the slurry out of the hole, so we have a good seal, and then we kind of scrape away this part of the slurry. So try not to leave a depression there, so the water will run down down near the probe. But so there's little practical things you can do. And maybe a little bit of a cone to keep the water from going down is one way, but also putting it on the downhill slope side. Normally I put it on the uphill side, though. All else being equal, if you have that issue, that might be something to try. Sometimes you have to pull the probe out and reinstall it. I've only had to do that a couple times, but once in a while we'll find a bad install.
Okay, great. Since drip irrigation is wetting such a small area, is the real value, and then there's a typo here, so I'm not sure I'm not sure how to read it, but is the real value to mitigate a low rainfall with early season use of drip irrigation? Does that question make any sense to you, Mark? I can't interpret this typo here. Is the real value in TRTING to mitigate a low rainfall with early season use of drip irrigation?
I'm not sure that means either, but mitigate, I'm actually not sure. Can you repeat that one more time? Maybe I can figure it out.
Well, let's do this. If the asker of that question is still online, maybe retype it, and
that'd be great.
And we'll get to it. And that's probably rather than kind of not misinterpret it. So next question. So without measuring the plant stress, it seems like interval would need to vary over the course of the season with the weather conditions.
That's true, and that's why this is telling you exactly what it really integrates everything, because we're looking at from point to point. So we have a reference point. Again, I don't really worry about the calibration equations because I have a point that's repeatable, or a measurement that's repeatable. So when we irrigate to a certain level of inflection on that curve, to vary the stress of the vine, we can see how much moisture has been being depleted. Now, of course, when the weather gets cold, if it does get cold or humid, the vine's transpiring less. You can kind of see that. It doesn't actually affect it as much as we think, but you do see that in the curve, and it will take longer to get to that point again, which means your interval may be stretched out a day or two, or shortened up a day or two. But that's exactly what we're learning. So with these probes, so if you really have a smaller vineyard and you can really dial it in, that gives you a good tool to identify exactly what that interval is. We're not guessing here; it's really telling you exactly what it is. Now, if you've got a bigger vineyard and you have to get around it, you just can't mess with these the probe telling you when to irrigate, but it'll still give you an idea of are my intervals getting shorter or longer, and you can apply that throughout the whole vineyard. So even if you're irrigating 100 blocks, you still can apply it, kind of in the way you do with ET. But in this case, you're measuring the depletion in the soil instead of estimating the depletion with the ET model.
Okay. Where do you obtain your NDVI imagery?
Well, that's a loaded question because I actually I partner with a company, but I've worked with lots of different companies. There's a few out there that are all good. There's VineView Imaging. There's Greyhawk Imaging. I do work with C3, and they're one of the newer ones on the block. They got a really good product, and they're able to remove some of the soil background from the plant background. So I don't want to plug it a lot because I do work with them. But that's a really good company to check out. They're new, but they've been around for a long time, and they also do soil mapping. That's why I work with them on the soil mapping. So there's a few different vendors out there. I would just call around and see what they have to offer price-wise. But NDVI imagery, or C3 has a different name for it because it's not exactly an NDVI. That imagery is indispensable and, frankly, very cheap.
Next question, Mark. Is there a parameter that can be configured to upload data to ranch systems that you know of? I don't know of any. That's more of a question for Jacob. So
I could speculate though, because the one I use is the Decagon one, and it does have an ability to export information. It does have a logger built in. You could export to an Excel spreadsheet or a CSV format, and that could potentially be uploaded. I've never done it because we enter our data into another database, but it could conceivably be done. But that is definitely a question to raise with the techies.
Yeah, so it sounds like it can. And Tyler, if you're still on the line listening, why don't you email that question directly to Jacob? I'm thinking he'll give you a much more detailed answer. How do you calculate the crop coefficient?
You have to guess. That's the reason I don't use ET any longer. I actually did some experiments when I was younger and had a lot more access to tools, expensive tools, to measure actual ET, something called eddy covariance, and we were actually measuring crop coefficients using the locally measured reference ET and then actual ET. And it really depends on lots of factors: row spacing, canopy type, trellis type, VSP versus a split canopy versus sprawl versus head train. There's all kinds of factors that go into that. So many factors. It is really an educated guess. I always refer people to Larry Williams' paper or article that he wrote for Practical Winery and Vineyard. I can't remember the actual date. I think it was in 2001. But if you go on Practical Winery and Vineyard's website and type in or search for Larry Williams irrigation, you'll find that. And he's got a table of some crop coefficients that I think are pretty good. All that said, it's still an approximation. Again, I think the evapotranspiration model is good, but doesn't account for what we see in grapes, which is stomatal closure. And grapes are very good at conserving moisture when they get even mildly stressed. And as the season progresses, they get more and more protective, and they require less water. They use less water. So that ET model, the crop coefficients, all really good, but it does seem to miss out on a lot of that water use efficiency that Vitis vinifera has. And because of that, that's why I don't use it any longer. But the crop coefficients are published and reasonably good, so I would definitely steer you to Larry Williams' work.
So here's a related question. So why not use KC of 0.18 instead of 0.5?
Okay, well, don't confuse KC with management coefficient. Kc is the crop coefficient. We normally would say, okay, that's our crop ET, but some people call it potential. Well, let's not even say that. It's just it's a model number. I don't want to throw too many factors into there, but you're right. It does. You could put a lower number in there, but normally what we do is throw in another factor on top of that, which would be the 0.18 called the management coefficient. Would you do that? Yeah, you could do that, but you're still flying blindly if you're not measuring it. So again, I believe that the small investment in the soil moisture measurement makes me sleep better at night, a lot better at night, because I'm not really worried if the vines have enough water to get through the next warm weather phase. You know, there's always going to be those coming around the corner. So yeah, you can do that, and you might want to try it. But if you're not measuring it, then good luck. And I wouldn't suggest doing that without having some reference point, whether it be plant-based measurements or soil. But again, I really like the soil.
Okay, great. Where do you put a probe on a hillside vis-a-vis the drip emitter? So I guess the question is it still 4 inches, or do you position it differently on the hillside?
Yeah, well, that kind of goes back to the other question that was asked, and I kind of answered it probably before or after he had already asked it. But I still tend to put it below the emitter. You might have a little more leeway there, but but you're still going to talk about within 6 inches of the emitter. Again, you don't want the water to run. The only place you're going to find water that's not saturated, saturated or free running is in the surface or very close to the surface. So you don't want water to run into that probe, potentially in the narrow gap between the probe itself and the slurry mixture that you put in there. So you don't want that to happen. You may, I hate to say do it more than once, but typically what I'll do is still put it downhill, but I'll try to talk about putting that little berm there so it's not running into the probe. It's very important. Those subtle things, it's not difficult, but there's some subtle things you do like that can prevent erroneous movement of water. And so I probably answered that question and you just asked it afterwards, but I still would go pretty darn close to the emitter.
Okay, and is this remote soil moisture monitoring technology and methodology practical for large-scale production-based vineyards, for example, 5,000 acres?
Absolutely. I'm working with a vineyard management company that farms about almost 4,000 acres, and they use them. And I'm trying to get them onto the remote. They're using the downloaded version, which I think they're going to eventually go the other way when these wireless ones come about. But absolutely practical. You don't need to. Again, you don't need to put it in every one in every acre. So you don't need to buy 5,000 units. Maybe you only need 50. Maybe you only need 20. But yes, I would not want to irrigate without them, frankly. Now, where it's more important, I think, when you're really doing the finer wine grapes and you're really trying to dial in the stress, that's where you need maybe more units. But when you have a more bulk, large-scale operation, especially when the soils are more uniform, then you can get by with a lower density of measurement sites. So I totally believe, and I know that there's large companies out there, Central Valley, California, Washington State. I know a lot of big vineyards, orchards. It's not limited to vineyards, of course. I'm a viticulturist, but there's a lot of these being used in tree crops, even field crops. There's really no limit on your size. It's just having the manpower, people power to interpret this stuff for you, so that you're not just the measurements. The measurements good, but it doesn't do you any good if you can't interpret it and you can't act on it. So you have to have somebody in your staff or a team in your staff that are excuse me that are looking at this information on a regular basis and making decisions on it and changing the way you irrigate. So there's really no scale limitations. It just depends on your staffing.
Okay. How do you reconcile soil moisture probe placement versus soil water redistribution? In a block, how many probes do you need to feel confident in the data? Shorter that's one question. Shorter interval weekly works for crews. What about for vines on North Coast hillside blocks? Was that clear, or should I reread it?
Reread it, please.
So maybe we'll take these into two parts. How do you reconcile soil moisture probe placement versus soil water redistribution?
Redistribution. Now I'm assuming a redistribution is really, I'm talking about irrigating, and then after you're irrigating, you have redistribution, which is capillary movement of moisture from that wetted zone outward to the drier soil. So I'm not really sure where that comes from as far as regarding sensor placement. It's still essentially put it close to the center of that wetted bulb if you're irrigating with drip. So I'm not exactly sure the question. Maybe they can clarify that.
Okay.
What they mean by that question.
So in a block, how many probes do you need to use to feel confident in the data? So I think you probably, we addressed that one already. And then the final question is shorter interval, quote unquote, weekly works for crews, but what about for vines on North Coast hillside blocks?
I'm still confused with what they mean by crews. Is it C-R-E-W-S? C-R-E-W-S,
yes.
Crews. As in field crews? I'm not really sure what that means, but shorter interval works for any soil because if you have a heavy soil, if we irrigate deeply, then the vines don't, they get a little too happy, is what we find. So if they get deep soil, you irrigate deeply, vines get happy, and then they get stressed between your irrigation periods, but they tend to bounce around. The shorter interval works universally because where you have less water holding capacity, you're irrigating to satisfy those vines' needs. And so if you're able to satisfy the needs of the whole vineyard with a certain irrigation approach, that tends to be the shorter, more frequent type of irrigation. I'm not sure what that means by crews, other than talking about that does take more effort to do it that way, because you have to have if you're talking crews, I'm assuming labor crews, and you have to get out there and switch valves more often. And it's true, they have to irrigate more often. It is a trade-off in efficiency, operational efficiency, and viticulture. So there's always that trade-off. So it kind of depends on what your price points are too. If you're growing a $2,500 a ton or $5,000 a ton fruit versus a $500 ton, you're going to do something different. So you probably aren't going to be doing the shorter, more frequent irrigations in that case in the lower price fruit, because you're not going to be able to justify the extra cost it takes to switch those valves on and off more often. So there's definitely economic trade-offs every time you do make a management decision, and that's just how it is.
If you had to choose one, which is more useful, perometer, pressure chamber, petiole fluctuation in conjunction with soil moisture monitoring?
Thus
what is
far,
kind of a complementary tool, I guess is the question.
Yeah, I look, the number, besides soil moisture, the number I look at mostly is the perometer number. That's a personal bias because I've used perometers since early 90s, late 80s or early 90s, and I'm very familiar with, I'm very confident in their number, and plus I think it gives more information on the stress level of the plant. It also gives you information on the positive aspects of stress. So and gives you a little bit more, I think, information on when the vine might be going over the cliff. So that, to me, is the better of the measurements. Now, that said, I still use our pressure bomb, and I still believe that's a really good instrument. We have a pressure bomb. We use it. We do both perometer and pressure chamber on a routine basis. I'm kind of looking at this petiole diameter sensor carefully because I think it has some potential, no pun intended, that it could be a really good tool potentially to use. I use the word again, to use on a system like ranch systems where we could monitor stress remotely, which would be ideal. I mean, to be able to do this remotely would be great. Not have to go out to the field and measure it. Not only saves time and effort and money, but then we'd have a continuous signal instead of a discrete one like every once a week. So, but that said, barometer is my current favorite tool besides the soil moisture.
So the typo was trying. Unfortunately, Michael, I discarded the question, so I can't go back to reread it. So could you just retype your question again, and we'll pick it up shortly. I think we're getting to the end of the questions. We don't have that many left here. Sorry about that. I have one variety, Barbera, that shows sunleaf avoidance at mid-range of pressure bomb readings, 13, 14, 15. Does this indicate that this variety needs more water than others?
Not necessarily. There are some that do that more readily than others. Barbera, I guess, is one of them. Zinfandel definitely does it too. Do they need more water? No. No, they just behave differently. They're more sensitive to it. As long as they're not defoliating, dropping leaves, then they're fine. That's just a natural way of conserving moisture by reducing the solar light energy interception. So no, not necessarily. If you're comfortable that the vines are getting through the season, ripening the fruit, then just the sunleaf avoidance is it's highly varietally different. Cabernet seems to be one that's kind of holds out there longer. Doesn't do that maneuver until it's really stressed. So there's quite a bit of varietal differences. Does it need more water though? No, not really. It's you're going to get benefit by mildly stressing Barbera just like you would on any other red grape. And if I really want to go into the more nuances of irrigation, I don't have time today, but if anybody reads my articles in Wine Business, I write about it frequently. And there are certain times of the year that, so let's not say certain times of the year, but certain times of the phenological growth of the development of the fruit that we want to have stress on the vines, and there's certain times of the year that's less important. And there's certain times you don't want any, like fruit set. So having stress on your vine is good, but too much is not good, and having it at the right time is ideal. So maybe you don't want your vines to avoid the sun in late September when you're trying to get them ripe. So then maybe at that point they do need more irrigation to keep functioning. But during veraison and before veraison and after veraison, that's the time when you really want to apply some stress. So maybe you're okay with seeing a little bit of sun avoidance at that point, at that time. There's lots of factors going in here. It's not easy to say. One approach or one observation is always what you want to see. It's really time variant, location variant, varietal variant, market variant. There's all kinds of factors.
So Mark, at what point in a new vineyard does this system become practical? I just planted this spring.
Well, I have people putting them in right after planting. So most of them are going into mature vineyards. So a lot of that has to do with just recognizing that they want to figure things out better. But you can put them in the first year because you're going to irrigate a lot differently. I mean, wouldn't it be great to see how your roots are developing? And I showed you those little squiggly stair steps. You will see those developing over time as the root system develops, and you can see how your roots are developing with depth over time. And so irrigating to that depth, you don't want stress. You don't want any stress on the vines when they're developing. So we're not shooting for that approach. Kind of like that. That vineyard in Napa that I did that little demo for was that was already third leaf, so it wasn't exactly young. But you can put them in the first year and you'll learn a lot. But it's up to you. Because you're not stressing the vine, so you're maybe not nuancing them that much, so maybe you don't care about measuring it. A lot of people will put them in the second or third leaf instead of the first, right after planting. But I think they have value right away.
Okay. Well, Michael, your patience has borne fruit. We've got your question online here. Since drip irrigation is wetting such a small area, is there real value in trying to mitigate a low rainfall season with early use of drip irrigation?
Well, yeah, that's. I think it's a good point. I'm not really sure exactly what you're asking, but low rainfall year, this year being a really good example. I'll tell you one thing. There's a lot more soil moisture down there than you think there is, and that's what I'm finding. People with soil moisture devices are less likely to say, I gotta irrigate. It's too dry, because we're seeing ample soil moisture in most locations, not every location though, down around 2 feet and below, or even 18 inches or below, or 16 inches or below. We're seeing lots of moisture down there still, although it is starting to deplete much earlier than, say, last year, where we had, in the North Coast, had quite a bit of moisture in May. We're still not through May yet, but it's looking pretty dry. But, yeah, no, there's definitely value there in determining how much moisture you have to start this season, and giving you some information on whether you should irrigate or not early in the season. There have been vineyards I've worked with that we have put on irrigation early this year, really early though, more on mud breaks shortly after, because I really don't want to start irrigating. We're getting kind of late now, but some places we're doing that. But yeah, it definitely helps you there to determine where you were relative to last year. That's the thing. That's the real advantage here, especially with ranch systems. You've got the ability to compare year after year, because all that data is there at your fingertips anytime you want it. So you can look at last year. Where were we last year, and where are we this year relative to last year? And I was just sitting down with a client yesterday, kind of forecasting, or at least roughly forecasting when we need to start irrigation. Because last year we started in August, and this year, no, it's not going to happen. We're starting in June. So yeah, that's a real value, but that's not the only value. I mean, just the active irrigation process is really where the value, I think, is in these probes.
Yeah, I just want to note we still have quite a few people on, and if any of you are interested in this technology, Mark is a authorized reseller for us. So you sort of get a 2-for-1 deal. You get the Ranch Master soil moisture monitoring solution, but you also get access to Mark to kind of teach you to drive it, and I don't think anybody knows how to drive it better than Mark. Next question. Seems that more frequent irrigations would keep chemigated fertilizers at the root zone for a longer time. Is this true?
Yeah, yes. Let's not say chemigated, say fertigation. Chemigated sounds so negative. But yeah, I mean, it's very true though. Deep irrigations past the root zone could easily flush nutrients past the root zone and make it difficult for them to come back up, especially nitrate, which is something we're always concerned about with deep leaching of nitrate into groundwater, which is a non-sustainable practice. So absolutely, shorter, more frequent. This is again another value of this tool is to measure how much we're not only irrigating but fertigating, so that if we see it going down and being depleted, we know that the line's taking it up. Whatever's not being taken up is hopefully being fixed in the soil, CEC, or at least not leached below the soil. Now the real problem with all this is not the irrigation; it's the rainfall that we get, like in the North Coast. So we have to be careful with our fertilization practices, especially with nitrogen. Not just because of irrigation, but because of the high amount of rainfall we get in the winter when lines aren't taking anything up. But that said, yeah, your question is spot on. That's exactly right.
Okay, and believe it or not, that's all our questions. So for those of you still with us, thank you for staying on. Mark, thanks so much. That was I think enlightening to say the least. So great presentation. Thanks. Thank you.
Thank
you. And we'll be posting a recording of this webinar on our website. I think Mark will have it on his as well, if you want to have a look at it again. So thank you again, and stay tuned for our next webinar, which is going to be a case study also on irrigation at Obsidian Ridge Vineyard. With that, we're going to have Peter Molnar and the owner of the vineyard, and Brian Ron, his irrigation consultant, talked about what they did to address their irrigation issues at Obsidian Ridge. Thanks again, everybody.